All right, I don't always do bell work in these videos, but I felt like this one was pretty important and quite exciting. If if I'm being honest here, we're talking about angles, right, straight, acute, and obtuse. Okay, so let's do a little matchy because these are going to frequently come up. Measuring between 90 and 180 degrees. That is going to be obtuse. All right. Measure equal to 90 degrees. That'll be right. Measure equal to 180 degrees. It's a straight angle. And last but not least, between 0 and 90, acute. Awesome. Fantastic. Now, this next one here says, if the measure of an obtuse angle is x degrees, what are the restrictions on x? Right, this is an inequality statement. All right, this will come up actually quite frequently when we're dealing with some different algebraic problems. How am I going to write that as an inequality? Well, we're doing a compound inequality. It's between two numbers, so we're saying something like this, and it's going to be between 90 and 180. Notice I don't have the equals underneath it, right? It's not greater than or equal to or less than or equal to. It's just greater than 90 and less than 180, okay? So it's between those two. It could be 90.00000001 and still be obtuse. This doesn't mean 91 to 179. Some people do think that. Nope. All right? It's bigger than 90, less than 180. And the same can be applied to an acute angle. All right? Between 0 and 90. So let's hop into measurements of segments and angles. My goodness, this is going to be fantastic. I can't even wait. I just want to get started. All right. First off, congruent. This is probably the most used word in the history of geometry, or at least in our class. All right. And we're going to use that dope equal sign with the little tilde on it. That's some fancy stuff right there. All right. That is our congruent symbol. I will almost never write out the word congruent. I don't have time for that, all right? I'm a busy person, very busy. Time is money. That ain't funny. I will be using my congruence symbol all the time. All right, so here it says C is between A and B. If AB is 10 and BC is 5, what can you conclude about AC? So we're saying AB is 10. Notice how it doesn't have the segment marking over it. That is correct, okay? Because we're talking about a length. We're talking about a distance between A and B. So it's written without the segment marking when we're talking about a length, all right? And then it says that BC is 5. Okay. What can we conclude about AC and CB, or BC? So we're talking about these two right here. Well, if the whole thing's 10, that guy's 5, then isn't this 5? So do AC and BC have the same length? And if they have the same measure or same length, they are said to be congruent. So we would write AC, the segment, dang it, there we go, is congruent to CB with the segment, okay? We could also say that AC is equal to CB in measure, because they both measure 5, right? But the segment marking, then we're talking about congruent, equal to, we're talking about length, okay? Because it's a number. All right. Those are some minor details that you'll grasp over time. All right. Parts of a degree. Total change here, we're moving into angles and how they're measured. All right. So generally speaking, for our purposes, we're going to be talking about degrees of an angle. We're not really going to get too much into the minutes and seconds, but we are going to introduce you to it here. It does come back up in later math classes, and you'll see a few problems with it in your homework. All right. So 1 degree has 60 minutes. And then 1 minute has 60 seconds, kind of like time, right? Therefore, and I'm going to give you a sec here. You're going to want to look at this. 90 degrees is equivalent to 89 degrees and 60 minutes, because 60 minutes equals 1 degree. 89 plus 1 is 90. All right. And then same logic, but expanding on that. 89 degrees, 59 minutes, 60 seconds. You'd never write it this way, but this is just to show you what we're talking about. Okay? All right, you'll see actually degrees, minutes, seconds. That's used frequently in navigation. Like if we're talking about coordinates and stuff, they don't want to use decimals. They'll use degrees, minutes, seconds. You'll see that on like maps and things like that, right? Because you guys are all about those maps and things. All righty. So now I want to change from degrees to degrees in minutes. Well, this is 61.5 degrees. Well, we said that 1 degree is equal to 60 minutes, right? So what's half a degree? 30 minutes. So we could do 61 degrees, 30 minutes. Lovely. Okay. Next example. Let's go from degrees and minutes to just degrees. Well, 45 minutes is what fraction of a degree? Again, we said 1 degree is 60 minutes. So we're talking about 45 out of 60 total, which would give me, 3/4, or we can think of it as like 0.75, because I think that's going to come in handy here. So we can say 60.75 degrees, or you could say 60 3/4 degrees. To do a mixed number like the last problem, but really, who likes mixed numbers? I don't. I like decimals or improper fractions. Mixed numbers, they just have no place for me. They're very difficult to operate with. But as a final answer, sure, either one of these would be Gucci. All righty. How are we doing so far? Excellent. Wonderful to hear that. Great. Whew. Simplifying. Okay. I'm gonna take a little. That's some cold water right there. I'll tell you what. All right, we're going to simplify this whenever we do some subtraction. Now, I'm going to line this up vertically. All right. I think that's helpful in these situations. So 123 degrees, 15 minutes, minus 40 degrees, and 26 minutes. Okay. So I like to think of this as in each chunk of degrees, minutes, and seconds. So 15 minus 26, I can't do that. So remember borrowing, go to borrow from your neighbor, right? This is going to become a 2, so it's 122 degrees. How many minutes are in 1 degree? 1 degree, remember, is 60 minutes. So what are we going to do? We're going to make this 75 minutes. 15 plus 60 is 75. Cool, awesome, fantastic, America. So 75 minus 26 is going to give me 49. One thing to practice, you guys, is thinking about maybe numbers that are close. 75 minus 25 is 50. Subtract 1 more is 49, right? I'm just doing that in my head, a little mental math. Although I am always strapped with my TA84. Yo-ro, we'll learn more about that later. You only round once. Mathematical accuracy. All right. Then we're going to subtract 122 minus 40. All right. And I believe that'll be, 82 degrees? I hope that's correct after me saying mathematical accuracy and doing, math in my head and, flexing. But there we go. Awesome. Fantastic. I'm having a great time. Are you guys having a great time? I am having a wonderful time doing some math with you guys. I've been utilizing this cool little video thing here in the corner. I'm a fan of it. I like being in the video. I got my America in the background. I got my green Supreme flannel on, right? Because I've been rolling through these videos today. So it's not that I just wear this every single day. I'm on my 4th video of the day here, so that's why I'm in the same outfit. Maybe I'll do wardrobe changes in the future. All right, moving on. Example 4. Find the measure of the angle formed by the hands of a clock at 2:30. Now, I've given you a circle. We got to add in the clock, all right? So I'm going to zoom in. Up at the tippity top is 12. At the side here is 3, 6, 9. Then I got 1 and 2. I like to divide this thing up to fourths first so that I'm not at the 6, when I'm only a third of the way around. All right, so that just helps me plan things out. Okay, so the hands of the clock at 2:30. Now, keep in mind here, and I usually like doing this one in class, and people get it wrong, and it's, and then I, put them up on the board, put them on blast. We have a learning experience. We all giggle and have a lovely time. But right now we're doing this via video. Okay, so at 2:30, my minute hand is down at the 6, right? Many of us don't remember how to tell time on a clock like this, so this is a lesson in itself. Now at 2:30, the hour hand is not on the 2. It's actually halfway between the 2 and the 3. So it's really right here, okay? Halfway. Now, if we're talking about the angle measure, okay? Degrees, minutes, seconds is not related to time. We're actually talking about the actual measure of this angle now. Well, how could we approach that? How many degrees are in a full circle. 360 degrees is correct. Well done, children. Okay. Now, how many sections do I have here? I have 12. Ooh. Well, isn't that wonderful? Yes, it is. Well, what's 12 or 360 divided by 12? If I divide that by 12, that's 30 degrees. So each one of these is 30 degrees. Okay. I'm not going to write it all over, but what I'm getting at here is, well, this would be 30 here, another 30, another 30. That's 90, but we're only going halfway. So this is going to be 15. Add them all up. That looks like 315. Those are brackets there, guys. 30 plus 30 plus 30 is 90 plus 15, 105 degrees. 105 degrees. Awesome stuff. Another example here. It says, given angle MAD equals 3x plus 20 and DAT, angle DAT, is 2x plus 10, find the measure of angle DAT. It should actually have an M here. I think it didn't copy correctly. Okay, there we go. Now we got it. Measure of angle DAT. All right, well, let's think about here what we know. Do we know anything about these angles? Well, here's something you're actually able to assume that we're going to get to later, is you can assume a straight line or straight angle, okay? So I can assume this is a straight line here because it looks it. I cannot assume a right angle. So I can't assume that this is 90 because that would just be the answer to the problem too. Anyways, that'd be weird, right? But I can assume that this is a straight angle, which is 180 degrees, okay? They do look congruent, but I can't say that they are congruent. But I can say that these two add up to 180. So why don't we set up an equation here, 2x plus 10 plus 3x plus 20 is equal to 180. Cool? So what we're going to do a lot in this class is we're going to take geometry concepts and apply some algebra to them. They're going to have like a little algebraic twist. It's good to stay fresh on our algebra because most of our math classes are algebra based. So I'm going to combine some like terms, 5x plus 30 equals 180. And I'm going to subtract the 30. I'm going to get 5x is equal to 150. Divide by 5. And what do we get? 30. Cool. Awesome. Fantastic. I'm not done. You're going to find that a lot in this class too. We don't always just solve for x. We do other things. We're going to plug back in now. I want to find the measure of angle DAT. So I'm going to take this guy right here. I'm going to have 2x, which is now 30, plus 10. That's 60 plus 10 is 70. My measure of angle DAT. DAT answer. Oh, man. What the heck? That answer is 70. That was hilarious, wasn't it? Angle DAT. No. There we go. Alrighty. I'm a fan of that. DAT. Oh. Alright, I got to move on from this problem, otherwise I'll keep on making jokes. Alrighty. Last one here. So it says, solve for R and M, and we're given that XS is congruent to YT. YS is congruent to XT. When we're marking these, we can mark with like little tick marks like that. And it's a little hard when they crisscross applesauce like this, but I'll try and place them somewhere near the middle of them. Those guys are congruent to each other, as notated on the diagram. We use 2 tick marks, 3, 4, so on and so forth, as we have more and more. So what does that mean? Well, if they're congruent, then they are equal in measure. And I have all their measures with the last 4 bullet points here, right? So if I said XS and YT were congruent, I can take XS, which is 3M plus 7, and set it equal to YT, which is 4.2 M plus 5. Cool. And then I can set up an equation for the other one, YS, which is, and I'll do it in green, YS is 3.5, I'm going to say 3.5 R, because decimals are a lot easier to work with. And then XT, which is 2R plus 5. Now, lucky for us, the like variables ended up in the same equations. We didn't have to solve a system here. We just have 2 separate equations. So what I'm going to do is I'm going to pause the video, I'm going to work it out, and then record again to save a little bit of time. Okay? But why don't you try it on your own? And there we have it, folks. M is 1.6 repeating, or 1 2/3, however you want to write it. And then R is just 2. Cool. All right. Well, that was lovely. I think that's all we got here for today. Go do some fun practice problems and stuff. Have a wonderful day. Keep it real, keep it fresh, and always remember to do your best.